the very simple ability of search expand can do a lot. And we found that in quite a few applications, just be able to search somebody and expand, that takes does most of the work. So let's see, I know there's a person and Dixon. Let's see, let's find the person. Let's put the person into the graph. We have Ella Dixon in the graph. You can see the properties. Now, let's expand on that. Like in this case, let's see who shared identity with this person, and if we can find a group of people all sharing some identity, like has a corroborating with each other. So now let's phone number, email, and social security number, and that is the shared identity. So the Ella Dixon has the 3 identities. Now let's select all of them. Keep on expanding. Wow. Now we see for each one of them, like for each email, there's some other people also using the email, or I think what is this one? Let's see. This is email. The single email is shared by 5 people. So that's obviously suspicious. Now let's select more. Let's keep on expanding email from. Let's see, can we get the fuller picture of? There's more. Okay, we're gonna keep on expanding. Yeah, we found the new people. Okay, we're gonna keep on expanding until it stops. Oh, that's it. So now we know that kind of gave us a good sense of this is a group of people that is working together for something that we not identify yet. But it's nice to be able to quickly capture that group of people that they all share certain identities, that it's obviously they're working together. And now what I showed you is a step-by-step expansion. This is very useful. However, you can do it easier. Let me find Ella Dixon and do it over again. But this time I'm gonna just let it pull all, like, let's see, give me anything within the 6 degrees. Let's say, just give me all. Right. So what it does is, in this case, is actually look for certain relationships, keep on expanding, and bring all the data together. So of course you can use a cipher to do this. And everything I show here today, I demonstrated with the GraphXR, which is built with the Kineviz, but you can use it in many other platforms, or you can build your own applications to do that. So now we see, let's see where, let me just arrange them into a circle, make it easy to see. So now we know those are group people that they shared identities and they colluding with each other. Now the next question is like, what they do, what are they doing, and what are the roles of each people? And now let's have this client selected. So the next one, we want to see what kind of transactions they have performed. Now let's expand. Control X, expand. So in order to find the transaction, so let's say, remember in the schema, if transaction is performed by a person to another person. And so in this case, what we want to do is finding out, so that's why I have 2 steps, and then perform from the 2. So that should give us any transaction that they performed. We should be able to find that. Let's do that. So that's interesting. I'm not sure if you see that, but this is interesting, actor. You see how all the money somehow goes to that person. And the people we start with, Ella Dixon, and this has a lot of transaction coming from those people. She collected transaction and then goes to somehow goes to Brandon McIntosh. So this is interesting information, and that's something that we discovered. And now let's see. Let's take this one. Let me take this as the lead. Actually, I'm change my mind. Let's put it in the right hand side. Let's see if we can create something easier to look at. So now we have a graph of if you can see all the money, all the transaction converge to this person, and this is a group in the middle that pass on the money, or either send the transaction over or pass on the money to Brandon. And I think there's a term for this called mule. So essentially, this Ella Dixon is a mule, and just like Brandon McIntosh is the so-called second-degree fraudsters. They don't directly involve in defrauding other people, but they are on the receiving end. So this is actually quite common in the field of collusion. Very often you will see a lot of actors that often they're already being marked as the bad actors or being on the watch list. However, they often have one or two the person that's hidden behind, that's not on the watch list. And when everything gets ready, they jump in to receive the money and disappear. So this is something very common phenomenon. I think this like a fraud detection data set nicely captured it. So this is good. I'm pretty happy with what we get. The graph itself is a little bit messy. It's a little bit complicated. And now, one of the important thing in graph analysis is how can we simplify it? Like, so there's a way of you store the data. When you store the data wants to be as close to like original information as possible, so you don't accidentally lose some important information. But when you visualize it, and that you need to be as simple as possible, so people can understand. Like for example, like here, I can pick up information here, but there's a lot of noises. So let's see how we can simplify the graph. Now, one thing you can tell is like, for example, there's a I believe social network number. There's a phone number here shared by multiple people. What if I just replace the phone number sharing with the people share identity? So let's do that. Let's go to let's build a shortcut, and let's go to a phone. Phone has phone number. It has phone number. Let's see. I want a new relationship has a share ID. It's not the directional edge. Let's run. And we're going to do the same thing with the email. It's also share ID. And with the social security number, has social security number, share ID. Now I have the share ID group. I can get rid of the email, social security number, and the phone number. You see the graph is a lot more cleaner. And we could potentially, let's see if I select Brandon, let's lay out to the tree. The graph is already much cleaner. We could further clean up this operation, like see, in this particular case, because there's only single transaction between pair of users, and we have seen situation that there's many transactions. Actually, later on, another example I show that. And you often want to, hey, if two people has a lot of transaction, I just want to aggregate them together into they have a transaction and tell me the amount of transaction they have. So in this case, what we can do is we can do another shortcut. Let's say in this right now, it's transfer in the middle performed. to, so we can send money to, and we can see use, let's get a amount. We can not just in situations where you have a lot of transaction between two users, you want to add them together. Right now, this will not do anything because there's only single transactions. So let's run that. Once it's done, we can say, hey, get rid of transactions. Now we have a much more cleaner graph, and we can say, hey, let's go to the relationship, or what is this? This is send the money to. Now we can see how much money being transferred from one person to the other person. So this is a way of now we very clearly identify who is the end collector. Let me think with the ring is probably looking more interesting. Yes, there's go. So this Brandon guy is where it received the money. However, there's other people's, like clearly this Ella and London, they are the mule. They are kind of collecting the money and transfer to Brandon McIntosh. So that's an interesting exercise. I think I went through this thing. Yeah, already went through this there. Yeah. So what we found out is the most common explorative analysis activities can be conducted by simple search, like you pull somebody and expand. Like you can say, hey, I want to expand multiple steps. But to perform this kind of a simple search expand, and of course you want to be able to merge the node if you have the same information come together. For example, you have a user A has a transaction that you expand. If the same transaction have relationship to user B, when it's expand from user B, it should perform an automatic merge. So it show you the graph. Now, this kind of activity very often is very helpful to identify a lot of missing informations, because like very often you design algorithm to detect certain activities, but the bad guy changed their tactic, and suddenly your algorithm fail to catch it. This kind of just simply search and expand will actually very often reveal what's new, what the new tactic being performed by the bad guys. And to just do this search and expand, you don't really need a graph database, because as long as you have especially the traditional data store, like is very efficient in injecting data, keeping data secure and organized. And you, as long as you can just send a query, fetch data back, and model that into the graph, like create a connection, you can actually do a lot of it. So, but there are a set of questions, like tasks you want to do with the data. This is often not sufficient. This is very often involved with the ask a question of how does two entity connected. For example, let's see, we want to where's my we have Ella and London. Okay, so let's delete everything else. So we want to see, is there any transaction that go from one person to the other person? How do they connect with the transactions? Like this kind of activities can be easily find from a pathfinding. Let's say control. Let's do expand. I want to. That's probably a 4-hop expanding. So let's select the relationship associated with transaction. So let's expand. There you go. So that shows me between those two persons, it's the transactions go through a Brandon. There has a common, in this case, a common receiving part of called Brandon. Another example we can see is Now let's see. Let's see. What's the other person like? I have no idea how to pronounce this. Okay. So let's see. We have this entity and this person, and again, we want to see how they are connected. Let's see. Let's try this one. Yeah. So now what we see here is, let's see. Let's make it a little bit cleaner. So there's many transactions going from Ella and this Vitae something entities, and here they don't have a direct transaction, but there's many transactions going through a third party. And so this kind of a search is actually quite important. And what we found out in the practice is the ability to look for multiple entities and pull out the information that connects them is the area that they traditionally often take an analyst and many hours work to perform. So once you have a graph database, you approach your data as a graph. This can be simplified to a mere minutes, and so this is not just a productivity efficiency gain, but really is a fundamentally qualitative change in the work you can perform.